we are happy to be here to give you some introductions in this field of business intelligence and tourism, which is a broad topic. Of course, in a one-day course, we cannot cover every detail, but we try to achieve this goal as best as possible. The reason why I say we is, as has already been said, it's my person and my colleague Wolfram Höpken. We did in the past quite a lot of studies in order to develop the field of business intelligence in the tourism domain. About the structure of today's lecture, in the morning hours I will basically introduce in the field of data mining techniques, as can be seen from this slide. First of all, we introduce into the topic in general, business intelligence, what is it about, what can be, what are the main differences to normal statistical approaches, and then step by step we'll build upon the various techniques from a pure methodological perspective. And then we apply those themes and approaches on web data mining, but from a very intuitive perspective first. As a second step, after a short break, I show you a very applied approach which has been theoretically conceptualized and implemented as a prototype in the Swedish destination Åre. It is a business intelligence-based destination management information system. So this is then the second aspect which you will hear after the break. And then even before lunch, Wolfram Höpken will introduce you into the exercise which is then to be done in the afternoon empirically with the tool RapidMiner. So the tool RapidMiner will be applied together with you on a couple of data sets. As I said, most of the technical and methodological details can be found in these two papers published by Wolfram and myself in the last years. So they can also be found in the Dropbox. I think you are aware that we have a Dropbox where you find all the study materials. I go back just a second to introduce myself. As Claudia told, we should introduce a bit a thematic overview. So my background is in business and economics, business administration and economics, as has been said, in Innsbruck in Austria. I did my major studies, what is also called habilitation in a German-speaking area, the tenure. And then after this academic achievement, I was the director of a competence center for information technologies and tourism. And here is where I met Wolfram Höpken, where he was also the director and especially the director of the technology field, for the technology, right? He was responsible for the technological developments. And since that time, we are working together in this field, but I'm professor at Mid-Sweden University since 2008, and where most of these areas of research interests are covered. As you can see, it's about destination branding, economics, and e-tourism. This is where our course is focusing. And throughout the course, if you want me to ask anything, please stop my talk and we can immediately discuss. Or if this is not enough, send me an email so we can continue our discussion. Okay, then let's start now with the data mining and business intelligence in tourism. First of all, we have to define what data mining is, as you can read, it's a process of discovering meaningful correlations, patterns, trends by sifting through large amounts of data stored in repositories using various methodological approaches such as pattern recognition techniques, statistical and mathematical techniques. So this definition is, in our view, very good because it shows that it depends, of course, on the purpose. What are we looking for? And sifting through means explorative. We have not a goal to validate a hypothesis or to falsify a hypothesis, right? We explore the data set for specific, to find patterns, even trends. So also pointing to a dynamic aspect that we can look into the, to extrapolate data into the future. And the data are typically of large amount. There is where the notion of big data stems from. And finally, it is not just statistical techniques, but also mathematical modelings and pattern recognition techniques, which is another word for artificial intelligence-based algorithms, which have a very different application approach than statistical methods. But we will see in a second. What advantage do these pattern recognition techniques have over statistical techniques? That the data assumptions are weak, meaning all distribution types are accepted by these techniques. So you don't have, as an when applying these tools, to analyze the data, to transform them in a way that, for instance, by logarithmizing the data, that they can be used for multivariate statistical analysis comparatively. So also linearity is not a necessity. And even the completeness is not a necessity. Data can be redundant, noisy, and dynamic, as it is said in the literature. And particularly, as I already said, the size can be huge, very huge, in terabyte amounts. So big that they cannot be stored on a simple PC or so. This is where the notion of big data stems from. We have this cross-industry standard process for data mining, also known as CRISP, where this is, as you see, a dynamic process approach cycle, which starts, of course, with understanding the analytical surrounding, the understanding of the analytical problem, which is also called as business understanding, because as obviously it is embedded in a business context. And then, of course, from this, the processes, the business processes, are mirrored typically by data, right? The facts behind these processes, which can then typically be extracted semi-automatically, fully automatically, however. And then, of course, data need to be stored and prepared, pre-processed, so that they can then be used for data mining or model validation purposes. So data preparation and data storage is typically also known as data warehousing, so that the data can be stored in a way that they can easily be extracted for analytical purposes. And then finally, the evaluation step implies an interpretation of the analytical outcomes, whether the model findings are plausible, whether they can also be used for decision making. So if the plausibility check is positive, then of course the next check is the feasibility check, whether it can be used for decision support in the business context. And then when it is really also implementable, that it can be used for future data, then it is also deployed, meaning implemented in a way that with future data set it can be repeatedly used. And this is why we talk about a cycle, and of course adjustments of the models are a necessary assumption. As I said, business intelligence is an umbrella term, right? Comprises not just the analytical aspect, but the entire spectrum of data handling, data extraction, data storage, data pre-processing, and data exploration, but of course also the data modeling. Let's start with data extraction. The extraction process typically comprises the identification of data. Where are the data sources? Where can the data be extracted? And how are they then transferred into a data warehouse and uploaded? Another term is also populated. The data warehouse needs to be populated. Typically, we have sources from the organization internal enterprise, but more important are of course external data from outside the organization. What is that? What does that mean? That the data stem from the customer about quality perceptions, various distribution sources, distribution channel data, and so forth. So this is very important that the focus lies on customer and product related data or characteristics. And the flat, as I already said, the data need to be organized and stored in a way that they can most quickly be regained for analytical purposes for data mining. A very typical aspect are database queries like MySQL or online analytical processing, also known as OLAP. A typical visualization is the OLAP cube. So if we have just two dimensions and one so-called fact variable, like overnights, then we can group this variable by the two dimensions, for instance, travel group and sending country. Then we have a very immediate understanding, explorative understanding of the data. And here it's then also possible to drill down or to aggregate and to change the visualization form very conveniently. As I said, it can be rotated, the ranges can be changed, and of course the dimensions can be changed, the focus of the scale dimension, right? So here we have another possibility to show this data. This is exactly the same. We have overnights and guest type and sending countries. So this is a typical OLAP approach. So let's talk a little about the notion of big data. As I already said, in tourism it's obvious that a huge amount of big data in the tera and also billions of gigabytes leads to terabytes. The big data evolution is taking place, especially due to the social media, mobile generating constantly increased data volumes significantly. And for the analysis of this big data amount, machine learning algorithms are applied not only for the analytics but also for the extraction of this data. Another characterization talks about the 4 V's, such as volume, variety, velocity, and value. Very recently, Mariani, Rodolfo Baggio, who was already here, and Wolfram and myself added 3 further V's such as variability and veracity and visualization as all relevant aspects in defining the characteristics of big data. This is obvious, huge volume, billions of gigabytes. Variety, that we have a wide range of forms and shapes. What does that mean? That they can be structured, unstructured. Structured means numbers, obviously. Unstructured, we have a huge array of unstructured data such as texts, sound, pictures, and so forth. Typically also temporally or specially tagged with information about the locus or the time tags or geographical coordinates. This is something very, very important to have this additional information in the big data. Velocity, speed at which data is created and modified, typically in real time. So data are not static, but they change very dramatically. Then the value can also change for individuals, be different for individuals than for organizations, and this is the reason why the data also became object of economic transactions, which we will also criticize now in the next slide. Variability, these are the three new V's, so to speak, that the meaning also varies. Not just the value, of course this is related to the value, but the meaning also can change dramatically across the various contexts and different time. And veracity, this is that the reliability and validity and completeness of data, as I already said, is not the core focus. Data can be incomplete, they can be redundant, they can be noisy because the algorithms allow these weaknesses. And finally, the visualization. There is a strong need to graphically present and explore the data, so to get a rough notion and a rough understanding of the data structure itself. Now before we start into the methodological details, some critical reflections. We are all young students, and we should also learn these developments from a more critical perspective as well, or not just take it uncritical, so to speak. One major critique can be said that in 2009, Anderson, for instance, claimed the end of theory and even disciplines because of the advent of big data. Why? You might have all heard of the various emerging disciplines, evidence-based medicine, evidence-based sociology, so meaning that researchers tend to reduce the value of theories, but just have a strong focus on the empirical facts, although forgetting that a fact is not something put in stone, and the etymological root of fact is facere, the Latin word. It comes from the human doing. So all the facts are the outcome of humans' actions and behavior, right? Therefore, although Anderson is, so to speak, reducing scientific work on the analysis of correlations and causalities, like it is just so something is going together, it has a similarity in the tendons, or is A presupposes B, so it's a directed causality, but it can be said it is needed a certain third level to understand the narrative context where this causality takes place, especially in a social embedded context, like business is, of course. So it's still very important in our views to not forget about theory, although big data analysis is not typically used to validate theories. But nevertheless, theories should not be replaced or even forgotten in their in their relevance. So since we have to find conclusions, we need reasonable narratives behind the knowledge development. So the end of theory would be the end of mind, because the real meaning can always only understood by putting into context. And to understand the context, we also need something like a broader theory, which is not in the data itself. It cannot be in the data itself. A second critique is that big data is also a big business, which is not necessarily following broad human targets, such as personal data, as we all know, can be completely commercialized. For instance, the US company Axiom, so it's not easy to pronounce, owns data of 300 million US citizens. It is said that this company knows much more than the FBI. But what is shockingly, it is that 70 segments, according to the buying power, the economic value of citizens, the segment with the least economic value is called waste, which is really shockingly and should not be accepted. But we know how much Americans have to accept, not only the president, so it's quite a lot of which needs to be criticized here. And of course also the digital market in general, in this vein of critique, became a synonym for the surveillance society as a whole. And therefore there is also this, beyond the business aspect, the potential to control human behavior. We also in this aspect there exists the notion of psychopolicy, better known eventually as from micro-targeting or target marketing. The principles of target marketing can easily be applied to voters. So voters gain or are targeted with very, very specific, personalized information to turn the voting behavior into most desired way. But the reason behind is that the free will in that sense is not even known to the receiver of the information. So it can be concluded that this micro-targeting transforms in tendency the Freudian unconscious ID into a conscious yet exploitable ego. So it is not here to, so to speak, transcend and to bring out the unconscious ID into a conscious, but the main goal is to exploit this ego, being as a voter or a consumer. And this is, of course, a critical aspect when it comes to free will. So we should have in mind these three critical pillars. One is a theoretical, more academic, and two are more practical aspects. But now we talk about tourism. How is data mining applied in tourism? Of course, in particular, larger companies such as airlines, intermediaries, online platforms are using heavily already today these techniques. But in contrast, small-sized tourism enterprises are lacking behind or need to catch up due to typically skill and budget constraints. What are the major applications in tourism? Segmentation. This is also something we will do with you and show you in various contexts. Customer segmentation, so the methodological approach is clustering. You can find, of course, also cluster analysis techniques in typical statistical multivariate approaches, such as hierarchical methods, but they are all less tolerant, as I said, with the data assumptions such as completedness and so forth, redundancy and noisy. So typically artificial neural networks, so-called cohonent networks, are applied for clustering and genetic algorithms. Customer relationship management, this is another important approach to discover those customer attributes or attributes of customers which are pointing to customers with above average propensity to buy and contribute to a company's wealth or profitability. This is known as classification. To classify whether a customer or any entity is part of set A, B or C. So you can see a typical usage pattern to first, in a first step, use cluster analysis to find segments and then use new data to see whether a new incoming, for instance, tourist is part of cluster 1, cluster 2 or cluster 3. This is exactly what classification is doing, and here beyond artificial neural networks, decision tree analysis are applied. Finally, demand forecasting. Demand forecasting is extremely important in a service sector such as tourism, because if we over or underestimate demand, then we have either waste resources or bottlenecks, right? We have critical queuing problems and so forth. So the forecast of demand is extremely important when it in respect to capacity management and revenue management. So, for instance, time series analysis using longitudinal data, again, artificial networks and all the parental approaches are applied, but also regression-based. Regression-based, this is a typical statistical approach, right? So finally, we have the travel decision making, and to study travel and decision making and buying behavior, also guest loyalty. Here, what can be used are a so-called association rules, so-called a priori algorithms or car nearest neighbor algorithms. We will show you now, step by step, these techniques. Some basic notions about machine learning are that we subdivide the major approaches, namely supervised learning and unsupervised learning. First of all, what is supervised learning? Here we split the data set into training data, where the tool or the method is going through a learning phase to understand how, so to speak, the variables depend to a target variable. It's very important that we have a target variable. In supervised learning, we usually have in the training data also the target variable. What can be a target variable? The target variable is the variable we want to explain, we want to forecast, right? We want to know what is affecting the target variable. So that in the future, if a model is learned, we can use data without the target variable, and then we get information about the target variable, the expected target. With new data, with unknown target variable, that's the goal. With unsupervised learning, the model is learned on the basis of all available data without any splitting into target variable or non-target or other characteristics or variables. So like clustering, in cluster analysis we don't have a target variable because we just include cluster building variables, and then we have an information, the outcome of the analysis is to see how many clusters we are and how we can profile the clusters. So we have not necessary to tell the analytical guidance what is a target variable and what is not a target variable, or any type of association recognition. So the target variable is not known a priori. This is the basic aspect to distinguish between supervised and unsupervised learning. Another very often mentioned and important aspect in machine learning is the aspect of overfitting, or better known also as overspecification. What is meant by overspecification? Holds specifically true for supervised learning. If each very, very specific structure from training data is considered in a model, then this goes clearly on the cost of generalization and stability of the model. So how can you intuitively realize this idea? If we have, for instance, a classification problem, the black and the white, whatever, then this model, of course, would 100% subdivide, but it looks extremely complex and unnecessarily complex, isn't it? Although this model, this straight line, shows very low complexity, although 1 or 2 or eventually even 3 are not correctly classified. But that would be better. It's not the goal to perfectly classify, but find a pragmatically a separator with not too high complexity. If the separator shows a too high complexity, then this is also questionable that this can be kept for future data set. You see the point? So it needs to be not too complex, and the goal is not to have a full separation. So error having an accuracy of about between 80 and 90% is more than enough. It doesn't need to be 100%, because this goes on the cost of complexity, and even unnecessary complexity, because the future data will nevertheless be somehow overlapped and not strictly divided. I suppose this overfitting problem is understood. Of course, there are some parameters which help us identify when, under which training phase overfitting problem could arise, so that training can be stopped. So now we start with this description, or with this analysis and discussion of the various data mining techniques. The first step is, of course, data description, the most simple approach, the descriptive, to describe the patterns of the data, relationships, trends, typically visually or in the form of explorative statistics such as the mean, the sum, the correlation, the standard deviation. So here, of course, there is a certain overlap to statistical explorative data analysis. No question. But of course, already here we can see certain trends and patterns in the data, especially when we look them in a multivariate form. An interesting example, historically it's quite interesting, because this was one of the first analysis in 2009, some time ago, to show the correlation, the strong correlative pattern between Google search volume and arrivals in the destination of Barcelona. And you see that the search volume is always going ahead about 2 months, 2.5 months, or about 2 months in general, and then after arrivals appear. Either they appear very strongly, or they appear even just in the same amount. So Google search volume became a very, since that time, in the study to forecast tourist arrival, search volume, especially Google-based search volume became a very, very important variable, independent variable to explain tourist arrivals. Much better than the typically used like income or GDP and or the costs, the price aspects of a destination. So this is an interesting example of such a correlative pattern of longitudinal data. Then, as I already said, classification is an important tool and method. Here, what is estimated is a categorical target variable. The target variable is, so to speak, the classifier, a category, a class. The model is built on the complete record, so we have the target variable to provide values for the target variable at the class, as I said, and the predictors. These are the input variables on the basis of test data. So it pertains, as we said some second before, to the family of supervised learning. For example, determine based on attributes like search patterns, booked products, to which of the three customer segments a first-time visitor belongs to. Here we have another very easy example, golf playing. Here we see a training data set of 14 days, 14 days of playing golf. When it's not possible, it says no, playing no, or playing yes, it was possible. And here we have some weather data, so to speak. Whether it was sunny, raining, overcast, the temperature data, humidity data, and whether it was windy or not. True means it was windy, false, it was not windy. And based on this data, a so-called decision tree, which is a classification approach, finds optimally out under which circumstances it is possible or not possible to play golf. Especially interesting here that the humidity threshold is found out, right? Under sunny conditions also humidity needs to be not over 77 whatever measure this is, percent I suppose. Otherwise the grass becomes too wet, then you cannot play golf. So this is a very simple example that then with future data you then just have to look on those data and then you know whether it is possible or not. I suppose you can see the relevance of this approach, right? So the flexibility, as I have already said, there are also similar approaches in statistical analysis, such as discriminant analysis or logistic regression, but they, as I said, require multinormality, multicollinearity assumptions to take place, and the linearity, of course. So these classifiers such as decision trees or artificial neural networks or association rules, which we'll learn in a later point, or Carr-Nearest neighbor, they don't require those statistical assumptions which are usually required for multivariate analysis. This is why these tools are so welcome and well known in the meantime. Here we have an example from the tourism domain where artificial neural network is used to explain the loyalty behavior. We'll revisit the hotel based on a number of perception variables from a customer survey, right? These data came from a survey and then it is seen like comparable to a regression analysis, which factor has the biggest impact on the revisit intention. And then it can be found out that, for instance, empathy, the reputation, and what else has an impact. Here this is a typical decision tree to finding out the most the travelers with the highest value for the company, for travel bureau, so to speak, which segment is most profitable, and it can be found out by asking simple questions then about whether already have been in China, traveling alone, already being in the USA. So after asking some core questions, it becomes then possible to understand in which category of a high value or a low value the customer might fall. This is another example well documented in the literature. Since I was talking now a lot of artificial neural networks, I take the opportunity or the chance to tell you some bit more in detail about artificial neural networks. Just as an example, an exemplary excursion. Of course, we don't have time in this one-day course to discuss all the data mining tools in detail. So we decided to just look on artificial neural networks, because you hear them also very often in the media, in the discussions, that they are so important. Eventually you have also heard the term deep learning, which is based on artificial neural network algorithms. Okay? So artificial neural networks are a powerful approximation of functions which are mapping complex, and here we have again this important aspect, nonlinear functions. So we have this nonlinearity built in. They can be used for a broad task palette, such as classification, explanation, and estimation. The difference between explanation and estimation is simply that estimation has the target variable in the future, right? And pattern recognition, so associative patterns. So neither model structure nor the data used are subject to distribution assumption, as I already said, no linearity, tolerant also to incomplete and erroneous data. This makes the tool or the method so attractive. So the image, the major image, is to rebuild the logic of the human brain. Namely, the neurons consist of a multitude of neurons combined into several layers. So such as our brain is not working, is by billions and huge amount more stars than the whole universe. We should never forget that we have many, I have forgotten the exact number, but our brain has much more neurons than the whole universe has stars, which is incredible. So we have really the neural architecture of our brain is something really inspiring. So nevertheless, a neuron is a processing unit. There is some processing taking place. This also shows the analogy to our brain, that the brain is the organ which consumes most of the energy, whether we think a lot or not, but it's a fact. But it's important that this processing is coordinated to other neurons, to one neuron, but eventually, or in most cases, many other. So they are a network of neurons. And all connections are equipped with now we come, of course, we are not talking about the human brain, but the artificial neural network with a weighting. This weight, that's actually the secret, or the very specific, the outcome of learning. You might have heard, even for human brains, the term tabula rasa. The philosophical concept of tabula rasa, when children are in philosophical terms meant to come on earth with a tabula rasa. The brain needs to be educated. And so it's also a kind of tabula rasa, a neutral artificial neural networks is trained to become weighted in a very specific way. You see the point? And this weighting scheme reflects then the state of knowledge about a certain problem. Right? So the flexibility of these weightings turns out to be the outcome of the learning process. So each neuron has a very simple task, namely to receive incoming input signals, X, I, from neighboring neurons, or neuron, just one or more, E, which in turn are controlled by the weights. This controlled is under parentheses. Controlled is also fine-tuned. We could also say fine-tuned, maybe because there is no controlling instance. There is a feedback instance, but so therefore fine-tuned might be the better term. The sum of the weighted signals represents the net input. You see, these weighted signals are summed. This is the sum. And to this summed net input, a positive or either negative value called theta is added. Here we see this theta. Defined as, this is also very much in analogy to the human brain, as activation threshold. Activation, meaning under which circumstances a process should be, so to speak, triggered or not, right? Because as we all know, our brain also at the very end is triggering something. But the question is under which activation threshold? Is it require, do we require, for instance, from a human perspective, a lot of stimulus or a little stimulus? And the same can be said here. If this theta value is small, then the activation threshold is low and the trigger is reached early. To, for instance, trigger, and this is then the next point, finally the activation function is then applied based on this summed weight, the weight plus the theta. Leads to the output of the artificial neuron. So we see that here the weights together with the theta determine whether a triggering takes place sooner or later. We could also say more easy or less easy, right? Like our brain is easily stimulated, or we need more stimuli. Of course, there is no psychology of artificial neural networks. Our human brains are working much more complicated. But this is just, we could also call it the mechanist architecture of our brain. And then we see that artificial neurons are arranged as, and now comes another, so to speak, architectural aspect which allows this learning and feedback. Transmit signals from input layer via one or more hidden layers towards an output layer. So this is where it starts, and then we have one or two or even more hidden layers. And this is actually where deep learning comes in. Deep learning has a quite large amount of such hidden layers. And this is the typical architecture or structure as we have seen here with different pictures. Again, here we see a linearity, or not non-linearity, but here we see the non-linearity. This activation function typically is where the non-linearity comes in. This is now to be set. This is, in input layer are usually linear activation functions, while neurons in intermediate layers and output layers are using non-linear, so-called sigmoid functions, similar to logistic functions where data needs to be transformed. This is one of the, I wouldn't call it limitations, but requirements of the artificial neural network. The data needs to be transformed in a range between 0 and 1. Otherwise, artificial neural networks would not work with the raw data. If we would compare artificial neural networks with a statistical method, then the most similar approach or method would be the regression analysis, because then the input neurons would mostly correspond to the independent variable, while the output neurons could be compared to the dependent variable, right? So we want to explain with a certain power, the highest, best possible explanation power, which are the determinants. So we assume a certain degree of causality. You see, there's a certain causality approach behind. And the two stages of the application of, here it should be ANN, this is the German, künstliche neuronale Network, also artificial, that's a typo, sorry for that. Two-stage application of artificial neural networks. First of all, a neutral configuration. As I said, the tabula rasa principle is associated, so to speak, with training data to achieve an initial output. But this initial output is improved through subsequent learning phases. You see, and again, we have a certain analogy to human brains if you think about children and so forth. This is also one of the secrets of humans' intelligence, that we have the longest youth time and time to develop our brains. The same is here. Learning phases of artificial neural networks can take some hours and some longer time periods, which is, of course, also to some extent a drawback of the approach, because it requires time. So the explanatory power of artificial neural networks is increased by modifying the weights, automatically, of course. This is a feedback process. This is also why the approach is called feed-forward multi-layer perceptron. It's feeded forward, right? Until the error between the predicted and the existing values cannot be further improved, or in this case minimized, right? So then an optimum is achieved. Then of course we have the same challenge to not do overfitting. So there is even the possibility, instead of just using learning data, have a third data set, validation data, a smaller data set than the training data set, and then do it with both. This is one of the approaches to avoid overfitting. As I already said, artificial neural networks have some disadvantages. The need to normalize the raw data into a range between 0 and 1, the relatively long training phase, and the kind of black box character. Black box means that it's not so easy like in regression analysis, that we have just to look on the regression coefficient where the biggest impact on the dependent variable is. That's unfortunately not possible to just look on the weighting schemes. That's not the true. So therefore a kind of sensitivity analysis needs to be done, right? To see what is the, so to speak, relative effect by triggering one variable in isolation, and then it can be learned and understood, but it's not immediately clear. This is also a disadvantage, but it requires some usage experience. I show you some example. This is, as you have already seen, this revisit intention. 25 satisfaction variables from a hotel survey have been factor analytically reduced into 8 input neurons with 6 hidden layer or intermediate level neurons and 1 output node, which is the intention to visit yes or no. So typically you would use logistic regression for this purpose, because logistic regression has the dependent variable in binary data, but what can be said from the comparison, that the accuracy and also even the explanation power with artificial neural network was much, much higher than with could be achieved with statistical approaches like logistic regression.
How do you verify this accuracy being higher?
Good question. Just by comparing the correctly classified with the non-correctly classified.
So collecting real-world data.
Yes, of course. It's always based on real-world data. So you just check how many have been correctly classified by knowing what the true class is that they said yes or no. This is exactly. So, and I think 94% of accuracy is a good measure. And then, of course, also finding out what are the determinants. Responsiveness, hotel room, location, and reputation are the main determinants of guest loyalty. So you can see a very practical approach of this artificial neural network. Another one is by Bloom. He developed artificial neural networks to segment or to cluster or to identify tourist segments, so it's a clustering approach, to subsequently assign first-time visitors to these segments. You see, I have said this already, the clustering goes very often together with classification, right? Because first we want to identify the clusters, and then we want to know whether a new customer pertains to cluster 1, 2, or 3, or 4. You see? And the first step is then cluster analysis or clustering, and the second step is classification, namely to assign cluster membership in this case. Cluster membership is a class. Cluster 1, 2, and 3 are 3 classes. So what he used, the data of a domestic survey, tourist survey of domestic tourists, 10 variables about demography, travel characteristics, and quality perception, and based on those he built clusters. And the output patterns of 10 input neurons of these 10 variables were the input nerve of a so-called self-organizing map. This is a special form of an artificial neural network. So now you see, you have already learned a new version of an artificial neural network, so-called cohonent networks. I don't go into the details, but specifically one advantage of those is that you can see them on a reduced data matrix visualized. And you see this data very clearly that these are 3 major segments. These are obviously an unsupervised learning. Separating characters in data set completely independently. The data analysis or the data led to a 3-cluster solution because this 4th cluster was set apart because of a minimal size. It was considered as too small, right? It's too marginalized. So then these 3 clusters have been considered as the main domestic tourist types. I don't go into the details how they can be described or profiled. That's not the purpose. The interesting step is that now in a second step, another artificial neural network determines the membership of the individual tourist by generalizing these found patterns in a classifier. So again, the artificial neural network with 2 intermediate layers has input layer with 10 input neurons, again these variables because they need to be known from the cluster building variables, and output layer was of course 1, 2, and 3. You see, the cluster, the segment was the output or the target variable. We could also say the target variable. That's what we want to explain. And after a moderate learning phase, each new domestic customer can immediately be assigned to a target segment. You see, again, an accuracy rate about even 97, more than 97%, which is very high, right? So by knowing these 10 information aspects of a customer, it can immediately be assigned to one of these 3 classes. Of course, reality societal realities in general and consumption and production realities shape and change over time. Therefore, this analysis needs to be repeated over time if we want, so to speak, understand the customer in such detail. Now we come to the third technique, estimation. Estimation is again a target variable which needs to be explained. Again, we have a target variable and independent variables or predictors. Therefore, it falls in the class of supervised learning. And then for new observations, the value of the target variable is easily estimated based on the values of the predictors. We all are, I suppose, aware about the statistical families such as confidence interval estimation and regression. But again, the most typical alternative from a data mining perspective would be artificial neural networks. As we have seen, the structure of an artificial neural network even corresponds to the structure of a regression analysis, doesn't it? Here we have the dependent variable and the independent variables. So therefore, a typical aspect is to estimate arrivals based on income, advertising, price, and so forth. Or, what we have seen before, also the search behavior on Google search engines. So this is a very recent research published again together with Wolfram and some students where we have done such an approach for the Swedish destinations. As I already said, estimation can be used if the target variable lies in the future, then simply it is called prediction. So you see, it's an extrapolation of the explained data or target variable in the future outside the data set. Then it's extrapolated outside, and then it's called prediction. Or forecasting is another term. It's again supervised learning, obviously. In future observations, value of target is based on values of the predictors. So the important is that here our target variable has then a t index which is not yet achieved. So then, to come to your question to before, we can of course compute accuracy only when the future has, so to speak, arrived. And then that's called then also the so-called forecast error. If we compare what it is prognosticated with that what in reality realized or turned out to become true. And this is then compared and contrasted, and the difference related to the base, and that's the forecast error, right? And of course, the forecast error should be as small as possible. In this case, it is even by just using a simple regression line below 1%. But again, this is important that you see typical statistical approaches again use regression analysis like this case, but data mining techniques, again, artificial neural networks, OK, nearest neighbor techniques. So what you see here is simply an application of a regression line with the equation which explains this empirical data in the best possible way, and then for the t time for the year, a value is inserted which has not yet arrived. So if we have the years until 2010, then we simply can impute 2011 and calculate, solve the equation, and then we gain a value for y at the 11th year, and then this is the forecast error, forecast value, and this is the reality after 1 year, which can be then found out. And by the way, these are real world data from Texas Airline. So it's often not so difficult. Clustering is another important approach to find classes of similar objects, homogeneous clusters with maximal similarity of objects within each cluster and minimal similarity of objects between clusters. So this is, so to speak, the formal verbal definition without using any formal notion, mathematical notion, but this is obviously what is maximized and what is minimized. This is the first example of unsupervised, because we don't have to split the data set into a target variable. Customer segments, market segments, typical approach by using a number of variables such as travel group, demographics, and here we have the x-mean and k-means. X-means is simply a further development of k-mean, implying that all different cluster solutions are calculated. A 1, a 2, a 3, a 4, a 5, 6, 7, 8 clusters, and then it's just looked which of those solutions fulfills this criteria best. You see? This, whether the within cluster similarity is highest and the between cluster similarity is smallest. The hierarchical cluster analysis, this would be a statistical approach. Cohona network, we have already heard, is of course a data mining approach. And here this is what we have already seen before. This is a Cohona network at work by using the test and the training data to validate these 3 segments we have already seen before. So this is the reason why I go a bit faster here. The next one is again unsupervised association, because again we don't have to split the data set into target variable and predictor variable. All data are included, so to speak, at the same character. What is looked for is attributes which go together, we have something in common. You know this, of course, from correlation analysis. A correlation coefficient also shows whether 2 variables have something in common, right? Having something in common means to have, for instance, a correlation coefficient of 0.7, meaning that there's a positive correlation that the variables grow together in the same direction. Here, however, rule induction is not a principle of correlation, but rules are deduced in that we see if an antecedent x is there, then with a certain likelihood the consequent y can be expected. You see? This is a further advancement of the logic of correlation. For instance, if room type A is booked, then with a certain likelihood additional offers B and C are booked. Then this is a if and this is a then condition. The antecedent leads to a consequent. And we have a number of, or actually a priori algorithm and generalized rule inductions, even decision trees to some extent. So this is a vision of the tool you work in the afternoon, the RapidMiner, and here is an example from the literature where menu configurations are found out by using a rule induction. Namely, if, for instance, vanilla chicken and corn soup are, so to speak, eaten, then they have been eaten with bread, iced tea, and mango cheese, and so forth. We have a couple of antecedents leading to a number of consequences. Of course, the antecedents can, comprise either just one or two or even three aspects. That's not explained here, but I think that's not necessary in this case. It's important that consumer-driven configurations of the menu card are easily possible by this approach. What you have seen is the support and confidence. What does this mean? The support is actually the basic probability that two items going together are both together. So this is the basic probability that two product items are both together. And the confidence, this shows how big is the support, the probability that product B will be both preconditioned that product A was already both. So this is the preconditioned probability. So if it is 50%, for instance, then in each second transaction which contains A, also B would be both. And finally, the lift implies that product A and B show a positive relationship. So only if the lift is typically higher than 1, then we can even purposefully analyze and interpret the outcome of our association rule analysis. And then the decimal point explains, for instance, 1.3, that the likelihood is 3 times higher that the A leads to B. What I have not said, that the typical approach is also called market basket analysis, because it is analyzed which products go together in a market basket. Now we come to the last aspect before the break, which is web data mining. All these aspects, all these tools are typically applied in a data mining approach. Here we have listed why the web provides such an interesting source of data, although only 5% are structured data. This is quite important to know, that 95% of the internet or data extracted from the web are semi-structured, like web or even unstructured text. Also semi-structured would be HTML, or unstructured are media files, metadata, hyperlinks, right? So not immediately usable for algorithms. Algorithms typically work with numbers. So they therefore need to be translated into computable numbers. But nevertheless, it's important to know that there is a dynamic and of course even a societal aspect, or services, tools. The web also provides tools which can be made use for this approach. So web data mining typically comprises 3 aspects: the hyperlink structure, the page content, which we also know as user-generated content, and the usage data, the search behavior, right? These are the 3 basic analytical domains of web data mining. In tourism, we have to say that it's still in its infancy. There is still a lot to research, and Wolfram and myself, we are here among the, so to speak, researchers trying to find out new application and new approaches wherever it comes to hyperlink, page content, user-generated content, and usage data. So let's start with the structure, hyperlink structure, web structure. It's basically then network analysis. And you had, I think Rodolfo Baggio was already here, so I don't have much to add here. The hyperlink structure is a very important domain to, for instance, find out which web node is an authority, a hub. So I suppose you have also talked about this virtual and real network. Then there is conclusions can be made even from the virtual hyperlink structure to the real network. Rodolfo, by the way, even set the term link phobia in tourism, which is interesting because the tourism, as being a highly fragmented and obviously connected business or phenomena, has on average only 2.8 hyperlinks on the websites, which is incredibly little. And this was even in on a island destination, the Italian island destination Elba. And Rodolfo could even show by simulating how by increasing just the link by one additional hyperlink, by pointing to another website of another supplier, would increase the information gain by tourists by more than 20%, which then of course also would imply favorable image increase and so forth. As I said, the next aspect is content mining or typical user-generated content, wherefore text mining is in case. So useful text is extracted from web pages, typically also social media sites, and then used to discover topics, to discover whether the statements are subjectively said or point on some objective statement, or whether the sentiment or the mood behind a statement is positive or negative. This is basically the three classes of text mining tasks behind text mining. And finally, web usage mining, which is also known as log file mining. Each click of searches in the web are typically stored as log file data in log file servers, and by analyzing this data, of course, new valuable, highly valuable knowledge can be found, such as clickstream analysis to see which is the typical sequence of website users, which are the preferences. By a search term is of course also a kind of content, but also stored typically in log file. Conversion, I'm sure you have heard about conversion rates. That is the ratio of lookers to bookers, you see. Then of course log file data is related to transaction data. And for instance, this data stems from a Scandinavian or Swedish analysis of log file data, and we found out for the United Kingdom, for the Åre destination, we had about 25% conversion rate, which was incredibly high, and the destination itself was not even aware about that high conversion rate, which usually lies below 10%. About 8% is a good conversion rate. If 8% of all the lookers would buy, so to speak, but in the case of UK it was 24%. So this was an example of a unknown, a priori unknown knowledge gain through web usage mining. So I think this was a quite crashy overview of data mining notions and methods and applications. I think we should go for a break, but before, of course, I'm open for questions if you have any. No? Then I would say we are back in a 11:15. Perfect. Nice to have you back in the second session of this morning meeting. As announced, this part is very applied now. to show you a case, a longer case study where business intelligence has been applied in a Swedish destination in mid-Sweden, in the Jämtland region, a destination which is quite famous, and I'm sure you all know the destination. It's called Åre, where the ski world championships take place also next year, by the way. The next year, the ski world championship is taking place in Åre again. And here we implemented some prototype, but of course I show you also the theoretical foundations of this prototype. The theoretical main consideration is the knowledge-based theory of the firm. Therefore, we also call this architecture the knowledge-based destination, or the knowledge destination. So what is the main idea? That the organization's value is limited by the amount of available knowledge to it. So you see, knowledge is here considered as a capacity, not necessarily as a resource, because knowledge is not something we can have like an entity, but knowledge needs to be embodied, needs to be understood. It's very much tied to the human's understanding, right, and capacities. But nevertheless, there are ways to improve this understanding and comprehension, and among other devices or approaches, artificial intelligence are such a mode or a vehicle to gain this knowledge. So lesser to the multiplication capability to produce more entities, to multiplicate in an industrial way, we are focusing more on the so-called replication capability. What is the replication capability? It has to do with the capability to reconfigure dynamically the capacities in order to create or co-create value with and for the customer. So therefore it's not like the multiplication capability is more directed internal to the company, to the organization, and efficiency aspects are typically in the center, right? But when it comes to external views or to the replication capability, to this evolutionary innovation oriented aspect, then external knowledge, not internal but external knowledge. And this external knowledge is basically stemming from the customer, right? Customer behavior, customer feedback, customer transactions, all processes where the customer is involved. You see the difference? So, and this allows to really increase strategic options. And it's not the typical efficiency gain, because doing something better internally to multiply industrially the production process, that is not what we are aiming for. And if we look in the literature again, destination competitiveness is defined by its natural, so to speak, given basic attractiveness, which is of course the many factors like natural, cultural, heritage and so forth, which are all known to you, but interestingly enough also this so-called self-transformation potential. This is this potential to best correspond or to focus on very specific tourist or visitors' needs and even wishes and desires and so forth. And so there is also in the literature the term or the notion of the learning tourism destination. As I said, knowledge is something which is not just a resource we can say we have it, but it requires a learning process, right? So therefore the learning tourism destination, or even the learning region and the learning destination is described in the literature as a region with a strong networked IT-based infrastructure which supports the collection of data and of course also the creation of findings and analytical outcomes which also are disseminated among the stakeholders of a learning destination. So it's about data generation, it's about data analysis, it's about dissemination of this knowledge in order to support decision making. So this is the basic idea. Now we have already this basically newly phrased term knowledge destination, right? So what we added to the literature, my colleague Wolfram Höpken and myself and a team, we added to the term learning destination the term knowledge destination. And what we mean by that, principally this is all clear to us that the majority of tourism information, transactions, communications processes today are driven or done and electronically and are mirrored and stored, so customers traces during all trip phases can be or could be achieved by having this data. So there is indeed a large variety and quantity of customer-based data in destinations. Remember, we said we are looking for customer data and not internal data. We are interested basically on transaction data, customer relationship management data, survey data, feedback data, or stored in websites, not only databases but also web servers, navigation and search data, user-generated content and alike. But what is the challenge at destinations? That this huge amount of data remains unused because of the highly fragmented nature and different formats the data is stored, right? It is text, it is structured data, unstructured data, and many different sources, data sources from different organization units. So our idea or our solution, proposed solution, was to apply automatic extraction methods to develop a new destination-wide data warehouse to store this data independently of the organizations, and we used for that purpose the open source software RapidMiner, which is exactly the tool you will use today for exercises and also for your home assignment. This is now the architectural framework, very easy to comprehend. There is a knowledge generation layer and a knowledge application layer. The first level, so to speak, or step at the knowledge generation layer is that structured and unstructured data have to be identified and within the destination. Structured data, as you know, are all figures, numbers, which have a clear structure, such as survey, profile, ratings, and so forth. But even it's interesting not only to distinguish between structures and unstructured, but also to explicit and implicit, which is intentionally or knowingly provided by the visitor, and implicit is not even knowingly provided. Meaning, for instance, navigation data, transaction data, if we, so to speak, book a holiday or room or whatever, we very rarely are aware that this data is of course also stored and made available for analytical purposes. The ETL process, we talked about it already. This is the extraction, transformation and loading into the data warehouse. So according to the data format, be it structured, semi-structured or non-structured at all, different automated or semi-automated extraction methods came into play, and all provided by the RapidMiner tool, such as natural language processing approaches, unsupervised and supervised learning techniques, wrapper technologies for websites, HTML documents, and structured data, of course, semantic approaches on ontologies to understand the meaning of the various data. Then the data warehouse itself is the central data storage where we had to develop, as I said, a certain tourism ontology. That means simply how we define what is a booking, what is a feedback regarding a hotel, what is a feedback regarding the destination, various activities at the destination, what means loyalty. So that has all to be done in order to map the data from different heterogeneous data sources into a homogeneous structure. Then here at the generation layer, of course, the application of, so to speak, explorative data analysis like OLAP takes place, or knowledge generation through methods, as we have heard this morning, cluster analysis, classification, association rules, and then the models need to be validated and can be implemented in the application layer as validated data models and OLAP ready to use for the management and the stakeholders, right? So here the interface, HTML-based interface has been developed, also called Destination Management Information System, which builds upon this data and these tools or techniques to gain ad hoc knowledge. Some more background knowledge. We have this indicator model where we looked on typical performance, economic performance indicators such as bookings, overnights, sales, customer behavior-based indicators such as web navigation, customer behavior such as booking changes, arrivals, cancellation, and also, of course, the customer profiles such as demographics, travel groups, and so forth. And finally, a brand concept, or a brand equity concept comprising brand knowledge, brand awareness, then a judgment, a quality judgment over the various destination value areas, and then a final satisfaction judgment, and loyalty has also been created in this course of analysis. These various silos of customer-based indicators have then been mapped to the trip phases and so-called processes, business processes from a data mining perspective. And we see that we have a pre-trip, an on-site phase, and a post-trip phase in tourism. Then obviously our first prototype was focusing in the web navigation process, in the booking process, and in the feedback process. So how are these processes now turned into a multidimensional structure, this process structure into a multidimensional structure by using so-called fact tables and dimensional tables. The fact table is always a core variable which relates to the core activity in this process, such as searching, booking, or being satisfied with certain activities or whatever, or being loyal. What are then the dimensions? The dimensions are, for instance, the date, the customer type, the demographics, as I said, the date, and the location where it regards to which village of the destination. So these are all aspects, contextual dimensions of the core fact variable. So these dimensions have a very important task in interlinking the processes, because typically knowledge is gained within these silos of one process. But through these shared dimensions, the processes can be, analysis can be done or are possible across the processes. You see, because the dimensions are the same for the various processes, right? A date is of course relevant for searching, but the data is relevant for booking, and the data is relevant when a feedback is given. The same customer type is searching, the same customer type is booking, and the same customer provides feedback. And why? So, in short, cross-process analysis are possible because of the use of these dimensional tables, or called shared dimensions. As I already said, the case study is implemented in the destination Åre in mid-Sweden, which should be known to you. It's part of the leading mountain resource of the world, among with Saas Fee, Val Gardena, Lake Louise, and even Queenstown. So these are very famous winter. So the focus is, of course, in the winter, although also a summer tourism is emerging in the last couple of years. Now we start already with applications, not all fully implemented in the prototype, but some, as you will then see. As you see, there is a strong research focus, as all those steps have been published typically at the ENTER. The ENTER you might know as being interested in the field of e-tourism. This is the yearly conference. The next year it takes place in Cyprus. I suppose you also know that Wolfram is in the board, in the IFID board, and so this is, as I said, an analysis of. It was done a clickstream analysis and a word search analysis and a analysis of the clicking behavior of the Åre destination website. Internal search, external search words, and all the categories offered in the websites. So 92,000 user sessions were available in the period 2008-2009. We did X-mean clustering to look on all cluster solutions between 2 and 30. So this is what I already explained. And what came out is a 3-cluster solution was maximizing, so to speak, the difference between the clusters and the within cluster similarity. And what was quite astonishing with this finding was that only cluster 1 and 2, the behavior is that visitors of the website remained on the website quite lengthy and for a longer period, 12 minutes each, and also did on average 6.4 activities per session, meaning clicks, or even 8.4, but it was quite bad to see that the huge majority, 88% of all users, or in absolute terms 80,000 sessions, had a very short usage time and did not on average less than 1 click. So just the half of those did even 1 click on average. So this is a very strong hint for a mismatch between the info need and the info offer. I suppose this is clear to you. And therefore also the website has been renewed, and there we see cluster 1, there is a specific information need on accommodation, and here on restaurant offers and eating and pub, and that could also be seen by analyzing the search words, the external and the internal search words, and then this is confirmed. These clusters have a very clear information need, but that's unfortunately not true for cluster 3, and obviously that was also the reason why these 80% of, or nearly 90% of searches had to be analyzed in order to find out what are other information needs. So another example is a decision tree. We have already talked about decision trees. Here the cancellation behavior is explained. We see that 8% of the bookers are cancelling the booking after having booked already. So the purpose of the of SkiStar in this case is of course to reduce the cancellation rate, which is about 60%. A decision tree is applied, a so-called C4.5 algorithm, and what, as you see here, it has been found out if the days to arrival is higher or longer than 42 days, then the likelihood increases 2.4 times that a booking is cancelled. And the ski pass, if that is bought very late, the last day, then it's even 3 times. And finally, if it's a first year arrival, after 2009, so to speak, then it's even 8 times. So it's not for the lawyer guests, but for the first year arrivals, 8 times higher. So therefore, if by knowing these facts with a very specific marketing approach, cancellation can be prevented. If you see this is first year visitors, this is people, ski pass is not yet bought, so then special offers for ski pass can be made especially before 42 days. So this was then also an obvious marketing strategy. Now we come to another example. As we talked this morning already, there is to distinguish between explaining arrivals or prognosticating. You remember? Here we explain arrivals. So within one period, actually between 2006 and 2012, the major sending countries of ARE come from 5 countries: Denmark, United Kingdom, Finland, Norway, etc. And here we see an example that advertising expenditures are also used as predictor. And obviously here advertising goes down and still arrivals go up. So obviously there is no correlation, isn't it? Arrivals still go up although advertising goes down. Here we see a strong correlation. As soon as advertising expenditures go down, also the arrivals go down. And so long they went up, mostly also the arrivals went up. So this correlation pattern is now used in a model to explain arrivals in ARE. Another most important predictor variable, as we have already discussed this morning, is Google traffic, right? The search behavior at Google. And here we see again strong correlative patterns. For instance, the Ski World Championship was an outlier. Obviously, then the destination became really globally famous. And interestingly, although more and more people looked in the website, fewer people arrived because of the fear to be in a very crowded destination. So, but nevertheless, for the image, the effect might be positive. But the immediate arrival effect is typically negative. So by using a number of other variables, such as the price of the income level of tourists, the price of other destinations, even the transportation cost approximated by jet fuel prices, then the advertising for various time periods, because as we all know, advertising takes time until it shows an effect. Then the online traffic, the event of the World Championship, and the focus on the winter and the winter season. We are looking for the winter tourist. So, and then we have here the major sending countries, right? And what we see, for 2 sending countries, Finland and Denmark, is something again quite astonishing, namely that even though the price, the costs of the destination are significantly positively related to the arrival numbers. That means usually economic theory tells us that if the prices go up, the demand would go down. But in this case, it's not the case. In this case, if the price would go up, we would attract more Danish and even more Finnish guests. because they are interested in this unique brand of Ore. And the same can be seen, confirmed, so to speak, internally, that advertising has a negative effect, because then it becomes a mass tourist in the place, in the image of descending countries. So this is also an interesting approach to use econometric approaches in a business intelligence setting by using also big data and advertising variables. Advertising variables only rarely are applied in, so to speak, explanation approaches of arrival numbers. As I said, beyond explanation, prediction, meaning the future demand, is a typical task. As you see, we have already talked about that many variables such as jet fuel price or Google online traffic have certain correlative patterns with the arrival data, but putting them all together, we can have a very smooth prediction to arrivals. We see that the forecast error becomes smaller and smaller through the inclusion of these various data sources. So this is just a comparison of the so-called mean absolute error, that it becomes significantly smaller by including big data such as online traffic. So this is just a comparison for comparing Denmark with big data and without big data, and also by looking comprehensively over the typically statistical approach, which is called autoregressive, that the information of the data, the time series data is used to prognosticate, or whether a nearest neighbor approach is splitting the data set into, or the time series in a predictor and target variable. And again, the mean absolute error can be reduced by even 30%, which is a lot. So this was also a paper last year at the Enter conference, not without proud I can say that this paper has won the Best Paper Award. Or was it no, this is 2 years ago. It was the last year, yes. So then it was not this paper, it was another. So sorry. So what we also have tested, that in another region of Sweden, that also user-generated content is shows very correlative patterns, the amount of user-generated content with the arrival data. Here we have the arrivals in Halland, in the region, in the south region, south Swedish region of Halland, and here the amount of user-generated content, and we immediately see this strong similarity of the correlative pattern. A so-called cross-correlogram shows this, that especially for the extreme short and 1 and 2 period, we can then use this to prognosticate arrivals for 2 months, 1 month ahead.
I don't know if you have said it, but can you just tell us a little bit about where you get the data from? So if you are talking about user-generated content, for example.
Yeah, these data, yeah, this is Facebook data, basically.
Okay.
And did we also use Instagram in Sweden? TripAdvisor also, TripAdvisor, genau.
So you extract the data
Yes.
from there?
Yeah.
Okay.
This now we come actually to user-generated content. This is an approach, again back to the destination of Ore, where again from TripAdvisor and Booking.com. Here we mention these sources explicitly. By automatically crawler were used to extract the data from TripAdvisor and Booking.com, comprising about 27 hotels of Åre, or in total some 300-400 reviews. Of course, we could only use the English reviews. That reduced the number of reviews to 208, which is not that big, but nevertheless we are focusing on each statement, each sentence, and not each total review, right? So therefore at the end we used 1,500 sentences. So then the preparation, pre-processing, the data pre-processing comprises tokenization. Tokenization means to transform the string of words into a string of words readable for algorithms, for text mining algorithms, where of course certain words are removed, the so-called stop words like articles, prepositions, they can be totally removed. Then verbs are reduced to the stem, the word stem. Going is just go, for instance, or so this is also a reduction and still keeps the meaning of a statement and can be better compared. Then point of speed tagging, then this is a tagging, an extra information at which part of this text or of the sentence the word stands. Is it the third word, the fourth word? Also that increases the information value of each statement. The same is true with n-gram creation. N-gram creation is nothing else than creating groups of 1, 2, 3, 4 words. And then you can, and then the machine learning methods use all these different sets to gain the most possible knowledge out of it. Because sometimes it's better to understand the meaning by using 3-word combinations and not 2 or even 4. You see?
In a sentence, how many words, or in general, in all the total review?
Just in one statement. Yes. Exactly. So it's the combinatorial approach, so to speak.
It's consecutive words. And only the consecutive words are put together. So good and not good as a new word. So only the consecutive words are put together to egrams or trigrams.
Yeah.
Not all combinations in the sentence.
Yeah, yeah.
Only the odd there together.
Thank you, Wolfram. Then a couple of machine learning approaches have been applied to see which is, so to speak, performing best, and contrasted to a dictionary-based method, which is not a learning method. As you see, these are learning methods, and dictionary-based method provides a priori words where we know, or at least through experience and through validation from past research, there is available so-called opinion words and even sentiment negative and positive words, which can help identify the subjectivity, whether it's some subjective statement and whether it's a positive or negative statement. And here we have the findings, and it can be clearly shown that the dictionary-based, especially when it comes to subjectivity recognition, is quite good, and the support vector machine is the best with a bgram approach, and again support vector machine when it comes to the topic. Properties, the topic. What it is talked about in the statement. What kind of topics. And then it's considered whether this is something subjective. So, and only if it is something subjective for those statements, a sentiment analysis is applied. Is it positive or negative? And then again we have this accuracy, as we already defined. This is the the share of correctly assigned classes by comparing the assignment to the real known class. Now I come to our next approach, the feedback data, which stems to this brand equity idea, where we consider destination awareness, tangible, intangible, and social dimension of the destination promise, so to speak, all destination resources which are judged by the traveler. This is also supposed to be the so-called brand promise. And this is then perceived, experienced, and remembered performance throughout the stay. And then, of course, final judgments exist about value for money and various customer dimensions, benefit dimensions, being social, being emotional, etc. And finally, this points to destination loyalty. So this model has been validated by a number of variables, which then have been integrated also in the prototype in order to find, I skip this because this just shows the validation process, but this is now the application with a regression, could also be done with artificial neural network, to see which of those many variables have the biggest influence on overall customer satisfaction for a certain summer segment, summer tourists in 2012. And here we see the biggest is that mentally it was possible to mentally relax, feelings of well-being, and so forth. Thrilling, there was also a thrilling destination. So this provides interesting insights into the drivers, so what is relevant for customer satisfaction. The same can be or will be done for destination loyalty and for various segments. So we also found out the key emotional value dimensions, escape, diverse, memorable summer experience, and training and exercise. So this could be done also for various a priori groups such as hikers, mountain bikers, and the village tourists. And finally, this is an example, association rules, so-called frequent pattern growth algorithms. We have already seen an antecedent, a consequent for attributes appearing together. And what we found out, extremely high confidence and also a positive lift, implying that is 3.3 times higher in probability, that if the satisfaction was critical, or so to speak low, with services and intangible attributes, then this leads to low value for money. If satisfaction with service is low and town planning and budget options for eating, then this leads to low value for money. Making a long story short, this gives us very concrete hints what are the critical factors for low experienced value for money. To understand what are the critical aspects customers experience as most critical when it comes to low value for money. The same has been done for cluster analysis on the base of this feedback data. So again, it has been all feedback variables had been included, and 6 cluster solutions turned out, 1, 2, 3, 4, 5, 6, and as you can see, they are all profiled quite complexly and not just briefly by demographic data, but by a number of, so to speak, feedback dimensions and behavioral dimensions such as length of stay, group, visitor group, and so forth. It is now interesting to relate these clusters to destination loyalty and see that, for instance, cluster 3 and cluster 5 namely the satisfied skiers from Norway and the satisfied international tourists, have the biggest loyalty. And again, the management can learn what makes those so happy. So then continue to doing the good, right? But what is also interesting to understand why this is the biggest, so to speak, source of low loyalty. These are the dissatisfied skiers from Norway and Finland. So the neighboring countries have a problem, and here it is described. They are dissatisfied with all core dimensions and many complementary service attributes, and a low emotional value. So therefore, here the search into the data can start for this Norway and Finland segment to, so to speak, try to reduce this bad performance, so to speak. And this is all knowledge which is, as you see, exemplary gained, hidden knowledge found in customer data. This is another approach of using Flickr data. This is an exception. It's not done in Sweden, but in Munich. So the first task is to identify points of interests derived from cluster analysis or true cluster analysis from Flickr data, because Flickr data are have a local, a point, a location-based tag and a time tag. And what we found out, and what was also the research goal in this research, that the density-based spatial clustering of applications with noise, this is an existing algorithm, works much better for a large-scale regional, large-scale environment, such Munich as a whole, not the Munich center, but Munich as a metropolitan area. Instead, a K-means clustering works best for a small, fine-grained area, such as a city center. And here we found out a couple of reasonable points of interest which we even could label, or which are obviously labeled already in the Flickr data. So this is the first approach to identify points of interest driven by the customer, shown and mirrored by Flickr data. These clusters can then be used for association rule induction, showing, for instance, which points of interest go together. You see, for instance, 1 and 3, Allianz Arena and the Innenstadt, then this leads to a high likelihood also to visit the Olympia Park. This necessary, and the same can be done for the Innenstadt, for the center of the city, 1 and 2. If 1 and 2 is visited, this leads to the visit of Neurath, the new municipality building. This does not necessarily show anything about the sequence. It doesn't mean that first 1 and 2 or 2 and 1. That can also be found out. However, the so-called sequential pattern analysis, here even the sequence can be found out. What is visited first and what is visited next. So you see, with this Flickr data, sequential patterns, association rules, and points of interest can be found out. And with different clustering methods, it is also possible to do this on a differently fine-grained geographical area. The city center versus the entire metropolitan area. Right? And this is now the, so to speak, promised prototype, the Destination Management Information System. This is the acronym, and we see 3 layers or process layer analysis layers. Here we have the very specific partner, the partner specific, or also / data source specific analysis level. Here it is aggregated, the entire process data are aggregated. And here even analysis are done across the processes. You remember, through the shared conformed dimensions, it is possible also to analyze between the processes. So we start with the web navigation. We see here a dashboard, a typical dashboard with typical website usage statistics, the top visited web pages for a specific hotel. Here it's just anonymized. Here, of course, we could have Dot Hotel or Copperhill Hotel. These are the partnering hotels of the destination of Aure. Then, of course, the click amount over the week, over the hours of the day, and so forth can be. This is a typical dashboard. But there is also a OLAP which can be manually, so to speak, adapted. In this case, it is the clicks per session per country. You see, this is a session. We have one from Kuwait with 20 clicks, or 200 from Denmark, 164 from Germany, on average 3.4 clicks. Even we can look on the product areas at the daytime and so forth. So this is all possible in the OLAP view. As you remember, we defined OLAP as having one fact variable and various dimensional variables. And here the dimensional variables can be freely chosen. Now we go to an order from the web navigation to the booking data and to another process, to another analytical level, to the process level, meaning that all transaction or booking data from SkiStar and DOT, in this case just two organizations, although SkiStar is very big in Aure, they comprise about 90% of all beds. So this is a very dominant player. Booking comprises, and here an OLAP analysis was done by looking various sending countries, travel groups, age ranges, and the booking price was summed. What does a sum of a booking price imply? It implies the sales. Actually, it's the sales. The sales for this, the sales level or sales contribution for this specific travel group or a priori segment. And then we see, if we let this order, decreasing the order, that this specific sending group shows the biggest contribution to sales in the destination of Aure. So it's the domestic tourist visiting Aure in as a travel group, being between 40 and 49 years, obviously showing the biggest contribution to sales. This was also quite interesting also for the partners, because typically we have this focus on international tourists. Here it was shown that still Aure is is relevant to domestic tourists, right? Then we go to the feedback data. Again, we have a dashboard view, guest profile, provinces, Swedish provinces, where coming from, agenda, travel, companions, sending country. If so, the Swedish provinces, of course, apply for Sweden and so forth. But more important, it is to look on the feedback variables itself. So here is a typical list of all feedback questions, which we gained from this brand equity approach, as you remember. So there are more than 30. Here are just, they are ordered by, one is of course the best, and here we find the worst. I consider Aure to be my first choice of a mountain summer resort. Oh, bad. This is a very important loyalty variable, and it turns out to be bad. So further analysis is needed. What might be the reason? So just an OLAP shows to look into this variable and group by length of stay. And then we see that especially those coming to Aure, those travelers coming to Aure for a short stay, don't consider Aure as their best choice. So then this relativizes already, although the relative size is biggest for this segment, so the others are not that bad. The long or the 2 week and the 1 week. So we see that this is just by OLAP we can find some reasons. Of course we could also now do a regression analysis, try to explain, statistically explain, or even with an artificial neural network, try to explain what might be the reasons for this low performance. You see, there are many of those ad hoc analytical purposes. Here I show you an approach to identify the customer or the traveler with the smallest environmental footprint. How did we this very pragmatically? Namely by using the literature by Sarah Dolničar and Reinsberg. They, through logical deduction and of course also by using the ecological literature, defined both socio-demographic characteristics but also travel behavior characters and vacation style characters, and finally even attitudes of nature-based activities / travelers, which point towards travelers with the relatively small environmental footprint. And now the idea was, by using our OLAP approach, filtering out these socio-demographic / travel behavior, vacation style characteristics / attitudes. And it was possible because we had many of those in our variables. You see, we used feedback value, the average satisfaction level, but we are looking for those activities in winter other than skiing, outdoor activities, non-skiing, getting in contact with local inhabitants, experiencing the natural landscape. These are all, so to speak, variables pointing at the environmental responsible behavior, and we found out that this is true for about 13%. It's not that much, but it is a base. It is a base which can be relevant. The interesting aspect is that they were even more satisfied with the destination as a whole than the typical skier. That's an interesting finding, that the environmental responsible, so to speak, traveler is also more satisfied. Less hedonic, obviously. In the summer tourist or season, it was even a higher share due to the nature of summer activities, which are by nature more or less nature consuming, environmentally critical, so to speak, such as biking, climbing, fishing, and also we had more of this group. So this is an example how, so here I remember to the analysis of user-generated content, which is then implemented also in this DEMIS-ORE prototype. Here you see the full review, but of course we said we have only looked on the English ones. For the analysis purposes, each sentence is then relevant, so you see also the sentence view, which of course relates to the supplier, where it relates to, even it shows where it comes from which data source, Booking.com or TripAdvisor, and here also the found topics from the topic detection are also added. And then of course for the partners we have a partner view, Copper Hill Mountain Lodge and Holiday Club and Dot Hotel, so we can for the various topics show how good they performed, normalized between 0 and 1, so this is a very important step, transforming text data into numeric values, and then of course also a sum value where this is all summed for all hotels in ORE. As you remember, I said the user-generated content was available in TripAdvisor and Booking.com, of course, for all hotels. So we have here the list of all major 19 hotels in Aare. So even though they were not partner of this project. And finally, by combining a matrix or table where we have all hotels and accommodation suppliers and all topics, we could show the relative performance, always between 0 and 1. A question mark, of course, if it's not possible because there was no topic mentioned about it, then it's a question mark. So this is also a clear example how complex textual data can be condensed and make comparable even among all the suppliers in a destination with relatively easy implementation efforts as soon as this basic research is done, as we have shown you. The basic research is to identify the most accurate and reliable topic and sentiment detection approach. Finally, we have this cross-process analysis view where we put together all these processes. For instance, then we can compare various aspects of the average booking price, the average time between booking and arrival, which might be very different for instance, if we compare France with Germany, or the average stay duration, or the average feedback. So it's better for the Germans than for the France, and so forth. So here are many possibilities to use the core fact data by choosing among the various dimensions. So of course this is just a prototype, therefore this layout is not the best, of course, but it is stems from a research project. But it shows that it works and that it is possible to combine knowledge from or data from the various silos of knowledge. And this is the important thing. So this is, now I am at the conclusion. This was a first step towards a BI-based knowledge destination, although the focus here was on web booking and feedback process, and most of the DEMIS cockpit is related to a dashboard and an OLAP view, meaning that the data mining models which you have seen before, cluster, classification, prediction, has not yet been implemented in the prototype, as you have seen. There are no, so to speak, prototype applications where these more complex data mining models have been implemented in the DEMIS prototype, right? So this is what is future work and ongoing work. Actually, Wolfram and myself, we are working constantly on this approach. And from a scientific contribution, the major performance indicators, the multidimensional destination data warehouse, so this data model has been developed. The DEMIS framework architecture, this knowledge, the DEMIS knowledge architecture, and the testable prototype, so that it can be also tested and used by managers, which provided us feedback to improve. And in the meantime, there is also a better solution around. And when it comes to Outlook activities, so you see that this cycle is not yet closed or needs to be closed. What we had so far is customer-based data, tourist feedback, information traces, mobility behavior, and then the supplier knowledge application layer with the DEMIS. But we could also, what we have not achieved yet, is more supplier-based data, such as product profiles, even cooperation network data, right? What you have learned with Rodolfo Baggio. Also that started, but I have not shown you, but we have done basic research also there to integrate in the destination data warehouse also network data. And finally, what we also would like to generate is and integrate is real-time data from real-time customer data. So feedback which is given in real time, especially through mobile applications. So that because analyzing automatically real-time customer feedback allows to provide intelligent, really smart mobile CRM applications, such as not only the crowd situation, but leading, for instance, visitors to point of interests with the biggest or highest relative mood, or where the match is best because knowing the preferences of the traveler. So this is a real-time recommender to some extent then. And for the management of the destination, the service recovery can be done, can be executed in real time. Real-time insights in supply shortages, query redistribution in smart business network. For instance, if there are certain requests and supply is full, and in a smart way it can be redistributed to other suppliers which still show free capacities, which best match to the requests of the customer. You see the point? So this is all what we are working currently, and this is basically not the architectural framework, but the logical framework, that we have two layers: a knowledge generation layer where the data is gained, created if it's not there. So as you see, this real-time data is not there. So therefore, mobile applications can be offered to create this data, which then at the same time are used to real-time business intelligence. So the analytics is done in real time to then feed intelligent or more intelligent smart apps. And then we hope to trigger a positive cycle of data generation and app use and increased experience quality of the traveler. You see this certain logic behind? But of course, research here is very scarce so far, or very fragmented typically. So the approach we gained or developed here is that it really tries to see the whole to comprise the whole destination, right? So not just to cut one view from customer data to supplier applications, but also supplier data which are relevant for the customer intelligence which is relevant to the customer and to the various stakeholders. This is the basic idea behind. That here a real dynamic also communication and knowledge/learning network emerges to the best intelligent use of these business intelligence applications, right? Do you have any? I think I am at the end. I said already that the next ENTER conference will take place in Nicosia at Cyprus.